Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. In this video, we discuss the solutions of 4 problems from the section Permutations and Combinations. It is the second part of the 3 parts of the video that is devoted for the permutations and combinations. Right. This question has appeared in the JEE Main exam held on 29 January 2025 in the second shift. The given question is, if all the words with or without meaning made using the letters of the word Kanpur are arranged in a dictionary, then the word at 440th position in this arrangement is. We are given 4 options. It is a regular routine question. Right. Let's now discuss the solution of the problem in detail. We have the word Kanpur and it has 5 distinct letters, and the letters of the word in alphabetical order is A, K, N, P, R, U. Right. Those are the letters in the alphabetical order. Right. Now we start, creating the words in our dictionary. So first it starts with A. So what is in our dictionary? How many words, number of words, and the cumulative number of words we write down. First, it starts with A. A, 6 letters, and A is present, 5 places are there. In these 5 places, you can fill it up with the 5 letters in any order we like. So that can be done in 5 factorial ways, that is 120 ways, and thus we get number of words will be 120, the cumulative number of words will be 120. After A, K, all those words which will start with K, and 5 places, and 5 the remaining letters, they can be filled in 5 factorial ways, that is 120. We have already counted 120, the cumulative is 240. The next will get N, and 5 places, 5 letters we have, 5 factorial ways, so 120 words you will get, and the cumulative is 240 plus 120, 360. So after N, P will come. After P, A is present, so PA, natural order, PA will be there, and we are left with 4 letters and 4 places, and that can be filled in 4 factorial ways, that is 24, that is 384. And after A, after P, after A, K, PK, again 4 places, 4 remaining letters, and in factorial 4 ways, that is 24, 408. So we are coming closer to 440th position. So let's go. Next is after K, it is N, PN, and 4 places and 4 letters remaining. So factorial 4 ways, that is 24. 408 plus 24, 432. So after N, P, N, you will get R, P, R, and A is naturally the first letter after R, so it will come. So 3 places and 3 letters, 3 factorial, that is 6 words, and the cumulative is 432 plus 6 is 438. Now P, R, A is over. All words which will start with P, R, A are over. After that, K. After A, K. And in the natural order is A, it will start with. And we are left with 2 places and 2 letters. In factorial 2, that is 2 ways. And 2 plus 438 is 440. So what is our 440th letter? So P, R, K, A, P, R, K, A. Who are the 2 letters left? N, U. What is the order? N, U first, then U, N next. So P, R, A, P, R, K, A, N, U. That is the 439th word. And P, R, K, A, U, N, one word, 439 plus 1, 440. So that is the word. That is the word. So the word at 440th position is P, R, K, A, U, N. So where is it? It appears against option 3. So the answer to this question is option 3. So that is the detailed discussion of the solution of this problem. We move to the next question. Right. This is the question that has appeared in JEE Main exam held on 29 January 2025 in the first shift. The given question is, let capital P be the set of 7-digit numbers. Capital P be the set of 7-digit numbers with sum of their digits equal to 11. With sum of their digits equal to 11. If the numbers in P are formed using the digits 1, 2, 3 only, again I will read, if the numbers in P are formed using the digits 1, 2 and 3 only, then the number of elements in the set P is, we are given 4 options. Right. Let's now discuss the solution of the problem in detail. We have P, the set of 7-digit numbers. These numbers are formed using only the digits 1, 2, 3, such that the sum of their digits equals to 11. Right. So required to find the order of P, number of elements present in P. Right. Let x1 be the number of ones, because we have to form the number with the digits 1, 2, 3. So the number of ones in the number is, let that be x1. x2 with the number of 2's, and x3 with the number of 3's used to form a 7-digit number. Then we have the following equations. First, x1 plus x2 plus x3 is equal to 7. Why? Because we have to use, the number has total 7 digits. Right. 1 times x1 plus 2 times x2 plus 3 times x3 is 11. Why? Because the sum of their digits is equal to 11. Right. And what are all x1, x2, x3? They are non-negative integers. They are integers greater than 0 and some of them can be 0 also. Non-negative integers. Right. Now take this second equation. From that, subtract the first equation. Then that will be is equal to 11 minus 7. When you subtract it, you will get x2 plus 2x3 is equal to 4. Only one equation you got, two unknowns are there. Right. So x3 can take the values 0, can take 1, can take 2. Let us see. So the possible non-negative integer solutions are, for this equation, when x3 is 0, substitute, x2 is 4. Then what will be the trituple x1, x2, x3? x1 is number of ones, x2 is number of twos, and x3 is number of threes. So x1, so x3 is 0, x2 is 4, but x1 plus x2 plus x3 is 7, then x1 will be 3. Right? So 3, 4, 0. That means there will be 3 ones, 4 twos, no threes, 0 threes. That is one possibility. x3 is 1, substitute. x2 will be 2. Then x1, x2, x3 will be 4, 2, 1. You got 2, 1. Sum is 3. Total is 7. Therefore, x1 must be 4. x3 is 2. Then you will get x2 is 0. x1, x2, x3 will be 5, 0, 2. Suppose someone says x3 is 3. If x3 is 3, 2 3s are 6. x2 will be 4 minus 6, that is negative. We don't have negative integers, we have non-negative integers. Therefore, don't go further. These are the possible non-negative integer solutions. All non-negative integer solutions we have found. We continue in the next slide. So, those are the possible non-negative integer solutions. Right? Now, let P1 be those numbers in P, the numbers in P are 7 digit, and this number, all those numbers which has 3 ones first combination, 4 twos. For example, 3 ones, 4 twos is our 7 digit number, and sum is 11. Like this one, etc. So many. How many? That's the question. So we will count them. Order of P1 is 7 factorial by 3 factorial into 4 factorial. How? Recall this result what we have studied. The number of ways of dividing n different objects into 3 groups of size P, Q, R, where P plus Q plus R is n, is given by n factorial by P factorial into Q factorial into R factorial, where P, Q, R are unequal. So in this case, 3, 4, 0, they are unequal. 3 plus 4 plus 0 is 7. So therefore, the order of P1 will be 7 factorial by 3 factorial into 4 factorial. Substitute here and cancellation take place. The answer is 35. Let P2 be the set of all those numbers from P, such that the number n has 4 ones, 2 twos, 1 threes. Like 4 ones, 2 twos, 1 3. Right? 7 digit number. Add them, you will get 11. And this is like this. This is also right. How many? That's the question. Order of P2 is 7 factorial by 4 factorial into 2 factorial into 1 factorial. And substitute, simplify, we will get 105. Let P3 is equal to the set of all those numbers from P such that the number n has 5 ones, 0 twos, 2 threes. For example, 5 ones, 2 threes. 7-digit number and the sum is 11. Like this, etc. How many? Order of P3 is equal to 7 factorial by 5 factorial into 0 factorial into 2 factorial. Substitute here, simplify, you will get 21. And we have got all possible combinations. Therefore, we have exhausted all the numbers of P. Now, we have P is the union of P1, P2, P3. We also note down that these are pairwise disjoint. That is, P1 intersection P2 is empty, P2 intersection P3 is empty, P1 intersection P3 is empty. When it is so, the order of P will be equal to order of P1 union P2 union P3. That is equal to order of P1 plus order of P2 plus order of P3. That is equal to 35 plus 105 plus 21, that is 161. Let's look at our options. Our answer 161 appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of this problem, and I like this problem. It's a good question. Right. We move to the next question. Right. This question has appeared in the JEE Main exam held on 28th January 2025 in the first shift. The given question is, let NCR minus 1 is 28, NCR is 56, NCR plus 1 is 70. Let A, the coordinates of this vertex A are 4 cos t minus 4 sin t. And this is B, is a print mistake, this is a B. B 2 sin t minus 2 cos t. And C 3r minus n, r square minus n minus 1 be the vertices of a triangle ABC where t is a parameter. Right. If 3x minus 1 whole square plus 3y whole square is equal to alpha is the locus of the centroid x comma y of the triangle ABC, then alpha equals. We are given 4 options. And let's now discuss the solution of the problem in detail. For you are given NCR minus 1, 28, NCR 56, NCR plus 1 is 70. And from these 3, find the values of n and r. Once you get n and r, the coordinates of C can be known. Then you can find out the centroid, and locus can be found out very easily. Right, NCR minus 1 by NCR is equal to 28 by 56. NCR minus 1 formula by NCR is equal to 1 by 2. Then it will be r by n minus r plus 1 is 1 by 2. Simplify, you will get to 3r is equal to n plus 1 is the first equation, let us say. Now, secondly, we take NCR by NCR plus 1 is equal to 56 by 70. Write down the formulae, that is equal to 4 by 5. And after cancellation, you will get r plus 1 by n minus r. Simplify, you will get 9r is equal to 4n minus 5. That is equal to second equation. And solving the first and second equations, we get r is 3 and n is equal to 8. Yes, yes, yes. Now, given the vertices of A, this is B, is not A, and C, 3r minus n and r square minus n minus 1. In this, substitute r is equal to 3, n is equal to 8. 3r minus n will be 3 3s are 9 minus 8, 1, comma, this is 0. This is 0. So the coordinates of the vertices are given here: A, B, not A, C, 1, 0. And now the centroid is sum of the abscissae by 3. That is 4 cos t plus 2 sin t plus 1 by 3. Y is y coordinates y sin t minus 2 cos t plus 0 by 3. Right. Now x is 4 cos t plus 3 sin t plus 1 by 3. 3x will be 4 cos t plus 2 sin t plus 1. 3x minus 1 will be 4 cos t plus 2 sin t. So the locus of the centroid is 3x minus 1 whole square plus 3y whole square is equal to alpha. 3x minus 1 I have already talked about, that is 4 cos t plus 2 sin t whole square. And y is this one, 3y is 4 sin t minus 2 cos t whole square is equal to alpha. Square them, that is the square of the first, the square of the second, and cancellation takes place. 16 cos t sin t and 16 cos square t plus 4 cos square t. 16 cos square t plus 4 cos square t is 20 cos square t. 4 sin square t plus 16 sin square t is 20 sin square t. Thus we get 20 cos square t plus 20 sin square t, that is equal to 20. So thus you get alpha is equal to 16 plus 4, that is equal to 20. Where is the answer? It appears again as option 3. So therefore the answer to this question is option 3. That is the detailed discussion of the solution of this problem, and it is not difficult. It is an easy thing, but it will take time, in evaluating all these, the values of r and n. Right. We move to the next question, that is the last question in this video. Right. This is a question that has appeared in JEE Main exam held on 28th January 2025 in the first shift. The given question is the number of different 5-digit numbers greater than 50,000 that can be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7. How many? 8. Such that the sum of their first and last digits should not be more than 8 is. We are given 4 options. Let's now discuss the solution of the problem in detail. We want to form 5-digit numbers greater than 50,000 with the digits 0, 1, 2, 3, 4, 5, 6, 7. They are 8 in number, such that the sum of the first and last digit is not more than 8. The sum of the first and last digits is less than or equal to 8. Right. So let us enumerate all of them. Numbers we write here. The number of such numbers we write here. First, let us take the first position 5, the last position, last digit 0. 5 plus 0 is 5, less than or equal to 8 is okay. And we are having 3 places. How many out of 8? 2 you have. No. These are 8 digits are there. No condition is given. So no condition is given. So for the first position 8, for the second position 8, the third position 8, because no condition is given. But I put a star here. Why? because for the choice 0, 0, 0, 50,000, that is enumerated, but we have to enumerate those numbers which are greater than 50,000. That means we have enumerated one, that I have to take care at the end of the solution that I have to subtract 1, because I have already enumerated, but we have to enumerate those numbers greater than 50,000. Right. Second, so 5 and the last digit is 1. 5 plus 1, 6, less than or equal to 8. Okay. And 3 positions, 8 numbers, no conditions are given. 8 into 8 into 8. So many. Third, 5, last position is 2. 5 plus 2, 7, which is less than or equal to 8. So, and first position, second position, third position can be filled by 8 numbers. So 8 into 8 into 8. 5, first position, last position 3, 5 plus 3, 8, less than or equal to 8. So we can tolerate this. These 3 places, 8 into 8 into 8. Now we cannot put to after 3, 4, because 5 plus 4 is 9, which is exceeding 8. But you have to consider only less than or equal to 8. Stop there. So the next number that comes is 6,000. So 6, the last question 0, 6 plus 0, 6, less than or equal to 8, and 8 into 8 into 8, 8. Now 6 and 1, 6 plus 1, 7, 7 less than or equal to 8, 8 into 8 into 8. 6 and 2, 6 plus 2 is 8, right? Yes, we can take it, 8 into 8 into 8. But we can't take 6 and the last element is 3, 6 plus 3 is 9, which is greater than 8. Therefore, we cannot go further. Stop there. So next is 7. 7, dash, 0. 7 plus 0 is 7, less than or equal to 8. Therefore, it's okay. So 8 into 8 into 8. 9. 7, 1. 7 plus 1 is 8, less than or equal to 8 is okay. 8 into 8 into 8. We cannot go further. Right. Stop. So these are all the possibilities. These are all the possibilities. These are the numbers that we have created. Number of such numbers are here. Each is 8 into 8 into 8. They are 9 in number. Therefore, the total number of 5-digit numbers greater than 50,000 is 9 into 8 into 8 into 8 minus 1 star, because we have enumerated 50,000 which we are not supposed to take, because we have to enumerate those numbers greater than 50,000. Therefore, I have to subtract. So that will be 4,608 minus 1, that is 4,607. Unfortunately, 4,608 is also given. Anyway, so in this, why I have subtracted? In this counting, 50,000 is included, but we have to count only those numbers which are greater than 50,000. Therefore, I have to subtract. Right. And the answer, so what are the options? The options are 4,607, option 2. The answer to this question is option 2. That is the detailed discussion of the solution of this problem. Right. In this video, we have discussed the solutions of 4 problems from the section Permutations and Combinations. And one of the questions, I told you that it was a very good looking question, and the answer is also pretty good one. Right. I am sure that you have understood the solutions of these 4 problems. Thank you for watching this video. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes. I am sure that I am going to meet you all once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.